Hello, everyone. I hope you can clearly hear us. Giran, how does it work for you?
Yes, I think so.
Cool.
Good.
Good.
So hopefully it's the last session for the day for everybody, and happy hours.
Yeah.
One session away.
Our today's talk is about the Databricks Apps, a new capability of Databricks which evolved over the last year, starting from a small private preview into a full-scale product surface. And in this talk, we would like to cover a lot of details. But prior to that, we must... Oh, does it work? Wait a second, I was clicking the wrong way. Yeah. So a quick forward-looking statement from the legal perspective. You know, it's not a big promise, right? So we may say some things, they are anticipated, okay? Good. Who we are. My name is Ivan Trusov. I'm a senior specialist solutions architect in the Databricks EMEA team. I'm physically located in Berlin, and still would be happy to connect with our colleagues and customers all across the world. My main topics of knowledge are Unity Catalog, serverless security, and Databricks Apps. I was always interested in building the applications, and when this capability appeared on our platform, I was really happy with that. Giran, to you.
Yeah. Hello, everybody. My name is Giran, a bit like the band Giran with a G. So hopefully everyone here is a Simon Le Bon fan. I'm also a solution architect here at Databricks, covering a variety of customers, mainly across Middle East and Africa. And previously to that, I spent the best part of a decade building and deploying mission-critical apps for a variety of different customers. So it's interesting to go full circle, learning about data and AI and how it scales and how we're then evolving and combining these two worlds together. So it's very much a passion project of mine, and very excited to be here today to speak to you folks as well.
Cool. Okay, Giran, would you like to talk a little bit about what we would like to achieve?
Yeah, of course.
Today?
And just a bit of a caveat as well, because when we ran this preview internally, this presentation, I know I didn't want to offend anybody here. I know some people are Christopher Reeve fans, but Henry Cavill's my Superman. I don't care what anybody says. But hopefully we're going to take you here from the left to the right. So for those of the folks, maybe I could, a show of hands, who here has maybe a background in data engineering, data analysts, for say, I assume majority of people here are, which is fantastic. Okay, for those in the room, who here comes from maybe a software engineering background, doing a bit of front end, TypeScript? Okay, so there's a bit mixture of bag here. That's great news, because today we don't want to make any assumptions. So again, whether you're starting your journey with building UI applications, we're going to be giving you kind of a level grounding upwards. So the idea here is to give you a bit of a talk in terms of how do we build this application with Databricks, and then also give you sufficient knowledge to think about, okay, what does it mean for your organization, and how can we enable for future use cases with Databricks apps?
Yeah. In terms of agenda, real quick, so we're going to do a quick intro, then we're going to talk about the frameworks and tooling that you can use to build applications. We're going to run through the topic of development lifecycle. Then we talk about the very important piece of apps, which is integration with other Databricks interfaces and services. Indeed, if you have an app, you want to test it before showing it to your end users, and we're going to cover that topic too. And when you tested it, you want to deploy it. So the question is how, and we're going to talk on that topic too, indeed. And then we're going to touch upon best practices as well as monitoring and observability, and give you a glimpse into the roadmap. Cool, Giran. Now this piece goes fully to you.
Thank you, Ivan. So let's kick into it here. So one of the things that we always get asked is, what do we actually consider what is a data and AI application? And the fundamental, you could textbook terminology, it's about an application which allows a non-technical, let's say business users, to interface with something through an interactive means. I would say everybody here today is a user of a data and AI application. So I'm sure if you are probably using some ride sharing, maybe like Uber, Lyft there today, if you're tracking in terms of your ETA, that's using AI and machine learning underneath the hood to determine like how far your ride is, and then also surfacing that in a way that makes you informed of those decisions along the way. The key thing with this is it's about connecting some of the very complex logic in the back end to something that's a lot easier to face and move forward. And in Databricks, there's kind of two journeys which we've seen so far. So I'm sure here today everyone loves a notebook, everyone loves getting, maybe those who are maybe less familiar with it, but again, notebook is really the heart and soul of Databricks. So when Databricks actually started its journey, one of the things they wanted to do was put a notebook, a Jupyter-style notebook in the cloud, and how to manage that for data science teams. But over time, it's seen a lot of love, seen a lot of development. But as you probably know, I don't really want to be giving a dashboard to my CEO or the CFO, right? They want, a notebook from this perspective. If you look at capabilities like AI, BI, for example, that's a really good way of being able to take some of that data and make it a little bit more accessible. But the key thing here is it's very much fixed in its nature. So it'll show data as needed, but there's no flexibility in terms of how we can edit and update that. And that's really where apps come into play. When we think about an application, it's that full customization, that flexibility that allows us to interact and update in real time. But to get there, we noticed that there's several challenges with it. Number one is around the complexity of it. So again, a lot of people who might start developing with different frameworks, if you don't know where to start, you may start looking at the web and looking through a whole variety of different technologies. And then actually getting into production is a bit of a challenge. Time to delivery is very, very important because with organizations like we have here today, there's always a need to update and iterate quickly. And then sometimes you might take shortcuts. And eventually that means there might be some security concerns that arise from it because people are putting credentials without even thinking about it. That gets leaked, and then we're opening ourselves to litigation and other financial implications. And this is a really interesting journey. So if you ever go on a website called roadmap.sh, gives you a career path of all potential tech career paths out there. So this is the one to start off as a full stack developer. So let's take a journey into how we would do that, okay? Number one is the language of the web. So you can't escape things like JavaScript, CSS, and HTML. That's the foundation for any web application. But on top of that, we may want to start learning about additional technologies. So for example, we want to be able to look at the wrapping of this using things like Node, being able to kind of connect to specific databases like Postgres for more of the operational things, or even Lake-based now that it's been announced. And then also secure that using your own security model. Last, you've been then hit in the face with, hey, I don't work in infrastructure. Why am I being asked to then deploy this on Amazon or Azure or even GCP, right? That sort of multi-cloud way of de-risking. So setting up things in relation to VNets, firewalls, security certificates, it's not something you would consider doing when you embark this journey. And going from here to there to keep going, and then you're just as confused as Uncle Jackie here, right? But surely there's got to be a ability to do this. Now, how can we improve the experience for the bunch of lovely folks that we have in the room here today? Okay, and this is really where Databricks Apps comes into play. Okay, for us, it's about not just democratizing data and AI, but also enabling you to get to building these data and AI applications as quickly as possible and giving you time to value so that you can delight your internal users as well as your customers. So Databricks Apps, again, very easy to build and get started. We provide out-of-the-box frameworks, and we're going to show you that in a bit more detail today. Very easy for us to operate. So again, using that serverless model, we can deploy things near elastic compute, and the ability then to kind of share that information out. So again, integrated with your workspace there today, as well as your identity provider, and to be secure as well. So if you're using your data in Unity Catalog, again, that's going to respect some things, and Giran is going to talk about this in a bit more detail, and as well as including things around accessing APIs and so forth, and other Databricks services. Again, really key to this is historically, Databricks has been used by data practitioners, including yourselves in the room, but now we're extending that even further to software engineers, because what we've seen in the general trend in the market is that we're bringing applications a lot closer to the data rather than bringing data to the applications. And what I mean by that is, as a full stack engineer myself, is historically these two, let's say, domains were treated in silos. So again, you have your separate stack for building and creating ETL pipelines to curate a data product, and then you bring that and copy that data over into an operational system. But now, again, as you've seen in the Reynolds keynote earlier, it's unifying that data, separating the compute and storage, a single copy of that data, which you can get access for both analytical as well as operational purposes. Okay? And just as a bit of a small subset of applications which we're enabling organizations today, it could be a simple dashboard, creating a chat application, to even go even more full-scale advanced data analysis and understanding and how that works through an agentic process there as well. And we'll be walking through some of these use cases as well in further detail. Perfect. But this sounds really amazing. But how do I actually start to consider what applications are in terms of tooling? Okay, I'm going to hand it over to Ivan to talk about that now.
Sure. Thank you so much, Giran. So, frameworks and tooling. There are so many, always disputes about engineers, which tool to use, this or that. The cool thing is that would it be Python or JavaScript or TypeScript or any specific framework, they all can be hosted on Databricks as soon as this is a web application. But from the overview perspective, just to understand, right? We consider usually grouping these apps into 3 groups. So one is apps that are built on Pythonic frameworks, such as Dash, Streamlit, and some other new, like Reflex, for example. Or you can build your application in a JS frontend and then plug it together with your Python backend. In this case, you will be doing like static site generation, and then your Python in the backend will serve the data to your frontend. And a very, very new announcement that came out today at the keynote, we also will support a Node.js runtime and a Node.js backend. So you will be able to run a purely Node.js applications on Databricks apps. Cool. But the question is, do I need an app, or which tool should I use? When should I use what? And we were thinking about this. I came up with this very simple concept. So take a look. If you want no-code, low-code data visualization, which only has some filters and a minimal user input, then you probably would just go with Dashboard. If you want your user to have a chat interface towards your data with minimal customization, then probably Genie is something that would be already quite sufficient for your case. But indeed, large organizations, enterprise scale organizations require more advancements, require more custom options. And in this case, you're going towards the Databricks Apps territory. For a quick start, and in case if your team has more skills towards Python, you probably would prefer one of the frameworks listed here. Shiny for Python, Gradio, Reflex, Streamlit, Plotly, and Dash meaning. Those would be your choices. However, if you want to go further, and if you want to have a very custom application or have specific UI-heavy components, you would probably look towards building your front end in JS or TypeScript and having your backend in Python, or even making everything in Node if you obtain these skills. Cool. But how do we start quickly? Can I just just spin it up and start it? Any of you can open your laptop right now, log into your Databricks workspace, and we counted this in 5 clicks. You will get a running Databricks application. Like, no joke, we specifically counted the amount of clicks. It is 5 clicks. And we provide a set of templates for you just to kickstart. But indeed, you may have your own organizational templates which enforce specific code styles or choice of technologies, and we also support this. Good. $1,000,000 question. So do we do this in Python or do we do this in JavaScript, right? And we consider the arguments for this in the following way. If your team is primarily, Python oriented, if most of your application is server-side logic with, just a set of user inputs, then probably Pythonic framework would be something that fits in your scenario. And they still can be extended with JS, JSX code for, custom visualizations. On the other hand, if your team has, experience in JS or very good at, vibe coding with V0 and something like this, then you may consider using JS on the front end, then generating a static asset out of this and serving this together with your application, right? In the practice, we see that JS native applications may have better client-side performance, especially for heavy UI operations, like when you need to do some 3D visualizations. They provide more styling capabilities with custom CSS options, styles, and Figma and everything. A very powerful combination that we explore we see this with a lot of the customers, is the following concept. So you have a single Databricks app, and it has two routes. One route closes the UI topic, and it uses static files, and these static files are generated from the UI, generated from the front-end framework, like classical combination of White, React, and TypeScript, for example. And then you have the API route, and this API can provide data in many formats. Can be REST, GraphQL, Arrow, and then you have clients who connect to this API. One more thing that we quite frequently observe is the so-called pure API applications. In this scenario, you don't even have any UI. You just want to serve your business logic in a certain specific way. And for this, Python with fast API, and you can easily deploy this on Databricks. A very convenient choice. We have seen this a lot, because this allows you to combine certain blocks of business logics under specific API routes. And given the fact that we now have Lakebase, if you have missed the announcement, you practically can build a full-scale application on Databricks, which will be able to serve thousands of users at the same time. Good. It was all slides until now, but we're here not only for slides, right? So let's take a look at this in action, okay? So how would that look for us? Sorry, where is that one?
First tab.
First tab, this one? Yeah, cool.
Yeah.
So let's take a look at what we can do with React on the full stack. If you don't know where is this located, this is map of Germany with data served from the Databricks SQL. And it has detailization level of 7 square meters. So this is the type of application you can build using Databricks Apps and Databricks SQL. This data is taken from HDX, Humanitarian Data Exchange provided by Meta. I must mention this. And as you can see, I can have all kinds of customizations. I can have all kinds of, interactivity on this map. So it's not, just like a generated static image or something like this. It is an actual application, which, we can also check the styles out and so on and so forth. How such things are built? Let me quickly demonstrate. So here is a quick example. This is the actual code behind this app. This app is, by the way, open source. You can find it on GitHub. Just search GitHub Telemetria, and you will find this application. So this is exactly how it works. On the front end, we have a piece of TypeScript, which was actually generated by ChatGPT. I'm really bad at TypeScript. And it just sends an API request towards the backend. And our backend serves a set of practically, it executes the query based on the incoming connection and then sends the data back to the client using Arrow format. What is cool is that since we're using Arrow, no need for double serialization, deserialization. We're just directly streaming the data down into the front end. And this allows us to easily work with this data. As I've said, this is open source. You can run it yourselves and build your application out of this quick example. Good, okay. Where do we have the slides? Here. Yeah. So with that was the piece of the demo for you. We're going to have a couple more, don't worry. And after looking at this, you're like, OK, this looks cool. How can I do it myself? And for that, you will need a little bit of introduction into the development lifecycle. And Giran, would you mind helping?
Yes, of course. Thank you, Ivan. So what I'd like to do is take a bit of a ground-up approach to this. And this is definitely that amazing future vision in terms of, again, how we're enabling customers to build that full-scale data application, combining the power of Databricks, as you know, through an easy layer. But OK, for many of you out there, how do we embark that journey? So one of the things I want to talk about today is around maybe looking at some of the Pythonic deployment with Dash. I'm going to talk a little bit in terms of the actual environment itself, like how it's actually created, what runs behind the scene, and then give you an idea when things go wrong and what are some of the things that we need to look out for. Because again, ideally we're like one-click deployment, everything works, but as you know, we need to iterate to make sure things are operational as needed. Okay, So in terms of the development lifecycle, so this is a bit of a simplified version, where you have your application code that's written in Python today. Again, and we also will be supporting Node as an environment. But you have your application code there today. You also have a YAML file, which tells you how the code is going to run, or its entry point, and also some additional configuration. So if you're declaring things like environment variables, as well as secrets, that can be deployed there as well, and your dependency file. So Databricks provides a set of runtime out of the box, but if you've got some additional custom libraries that you want to use, even if it's something that you've built through your own internal private repository, we can pull that in for you to use within the application itself. Once that's available, you then need to push that and publish that to your local workspace. So again, we're using synchronization there. Ivan's also going to be talking a little bit about from like how do we industrialize that using a CI/CD approach. So we'll be talking about that. But as a general purpose, we upload it to the workspace. You then need to create an application slot. So this is going to be a specific unit of work. Again, it's a type of compute that we have developed in Databricks where that application can run. So think of it as just like a Kubernetes pod, for lack of a better word. And then, again, it's how we deploy it. So you take that code, deploy it, install all of its dependencies, and then it's served through HTTPS. Okay. And just to give you an idea as well, between this, again, we support different types of environments, and again, it's about that synchronization of the code, having the latest changes, or depending on what kind of branch. We'll go there in a little bit more detail. And just to give you a feel, again, for those who are maybe not as familiar with application development, we're going to be walking through this right now. We'll take our template, which is off the shelf. We can modify it as needed, and then have a quick development loop iteratively as well. So again, here's an example where we'll walk through this. Okay, so with that in mind, let's go and create a Databricks app from the template. Okay. So I'm just going to take a look here. So we'll just drag all that up across. Okay, perfect. So just going to go here to my dash application. So underneath compute, so you might see this at the moment, we have a list of compute types. So you're probably well familiar with using things like classic compute as well as a SQL warehouse. There's a new one here that says apps. This should be available in your environment for, I think, majority of users here today, subject to region availability. But this now becomes available. What I'm going to do here is click on Create App. And I can either, for more advanced users, or we'll do it later, to create things using custom application code. But for now, again, I'm a new user at Databricks or developing applications. I just want a quick starter introduction. So as you can see here, we support all of the common frameworks as mentioned. So Dash, Flask, Gradio, Shiny, and Streamlit. In this case, we're going to be clicking on Dash for our data application. In this workflow, what's really important about this is apps can provide a set of isolation like any other type of securable asset within Databricks today. So it's not that case that we spin up an app and everyone has access to it. We can make sure apps are using the resources as permitted in control, to put the guardrails and control of your organization in place. So in this case, I'm going to specify a specific warehouse. I then want to give it a set of scopes. So this is really, really key as well when we do some of the on behalf of authentication workflows. And in this case, I'm going to give it an app, say, I'm going to call it UI dash, okay? And it's critical as well because we are running on a serverless control plane. We're able to also apply certain tags and budget policies accordingly with that. So in this case, I'm going to install and let that go through, and therefore now we've already deployed it. Initially, it's going to take a couple of minutes just to make sure we actually provision the application code, but just like a cooking show, I've got already something baked in the oven. So just to give you an idea here, I'm going to go once that's available. And you can see here that I've got an application running. As I mentioned, it's part of your Databricks estate, so it's a new capability, but because it's already working with your workspace, you have a secured endpoint, which we then can click in. It actually tells you where the application is then being deployed to. So when we make changes, it's then available, and also the resources associated with that. So with that in mind, I'm going to take a look at the application here, which I've got running. So in this case, we're taking, I think everyone's probably seen this, the taxi. It's a surprise, surprise. But it's just an idea of taking the data set and being able to visualize it. But on the back of this as well, we're actually doing sort of a prediction, a classical machine learning algo. So in this case, let's say I wanted to look at a particular time. Well, let's say I'm looking a pickup code from 003 to 002. Maybe I want to do 0022. 10022, right? So I want to do a prediction. So what this means is I can go fire into our model serving endpoint and it'll give us an update. So maybe the fare is 99 already. But just to give you an idea, again, that data has been queried through, actually no, it's updated. So it went from 99 to 12, so we've done a prediction on there already. So in this case, it's showing all of that taxi data set that we had available. And just as an example to this, so you can see I've got the taxi fare distribution as the title. Maybe I want to change some things on the fly, right? So I'll take a look at the code. I'll bring that up. So you can see it has that structure that I mentioned. I'm going to go into the application. And again, this is also open source, so this is available for you to use, to configure as needed, but just provides an entry point to it. And let's say, for example, then I wanted to trigger something like taxi fare distribution, or say something like map, for example. So I'll save that down. And then I'm going to go into this UI here and click deploy. And in near real time, it's going to pull in the latest code changes. And because we're already running compute, you can see we've just done it in a matter of seconds. And again, this is actually happening live. And you can see I've changed the title already. So you can see how quickly it can go from ideation to production in a very short space of time. Okay, well, that in mind, now that we've seen the Dash app, important to think about where's this actually running. So I mentioned around this runs on the Databricks serverless compute. So just to give you an idea, today, each application slot, we're giving you 2 vCPUs, 2 cores, as well as 6 gigabytes of RAM today. And what this means is this can run, again, a very lightweight application. And something to bear in mind with a lot of the folks here in the room today is, I want to make this kind of crystal clear in the fact that Databricks Apps is really intended to be the lightweight orchestration and UI framework. It's not intended to do heavyweight, computation lifts, things that you would traditionally think about, Spark and Photon. What we do encourage is users to actually push that compute down into serverless, into the jobs, into things like the model serving endpoints, if you want to call your LLMs, as well as your SQL warehouse to do those works. And even now that we've introduced Lakebase, if you want to do operational work, you can integrate there. So again, I wouldn't want to do within the application. It's just take the request from the user, then offload it to the appropriate compute as needed. Key thing here as well, again, similar to the Databricks runtime, we provide a secured hardened Linux environment, so all of the security libraries in place. We also provide you, again, Python 3.1.1 out of the box. We'll be upgrading as well as it see fits, and we provide an isolated virtual environment. So the requirements file that you provide, if you've got any additional libraries, that's going to be installed, and then the application code will run. Key thing here as well is that code will be bring up from the workspace. So again, as that changes, like I just did on the fly, it's very easy for you to deploy and make that available. Key thing here is around, again, when things go wrong, what are some of the things that we can do with this? And I don't know, maybe even you want to maybe touch upon some of the stuff as well?
So practically, we can kind of group the problems into three blocks. First one is code failures. As of now, we cannot immediately fix logical issues in your code, but you all know how to do this nowadays, right? Assistant, Copilot, anything like this would be able to help you. It is really recommended to test the application locally before deploying, and we have a whole section about this today. Verbose logging really would help you, and monitoring and observability, and also talking about this closer to the end of our talk today. Second thing that usually, somehow happens wrongly is the environment configuration. And, if using Python, use Pydantic settings to verify the validity of your settings at the moment of application startup, not at the moment when user hits the application, right? If you're using JavaScript or TypeScript applications, they sometimes have some issues with cores that probably could be the reason of the problems. Please do not use personal access tokens. Do not put them in the code. Do not get them from the secrets. Application is automatically configured to use specific tokens, and user tokens will be provided from the request header. I will show this in a moment. But in any case, do not use personal access tokens. No need to put them in secrets. No need to write them into the environment variables. Yeah, and in terms of startup, just make sure that the startup command you are running is correct, and avoid using relative paths, because the paths in the container are different. So always use proper relativation to the root of the project. Okay, that would help you. Good. Giran, shall we move on? Yeah.
So this is an interesting one. So we've now got the application running. Again, now that it's on Databricks, why wouldn't I want to bring some of the services that we have available? I think even you were touch upon this as well. If you want
Good.
to. Yeah,
I'm going to take care of this. So applications, like practically, it's just static content if they are not filled with data. And the question is, okay, so what data can I plug in? And the answer is, well, pretty much any data that you will have on Databricks, and even in the external services. So first of all, just Databricks native services like SQL Warehouse, Spark Compute, workflows, vector search, serving endpoints, anything can be easily plugged in and worked with through the Databricks SDK for Python, and there is also one coming for JavaScript, TypeScript. You can trigger workflows, you can embed dashboards, you can write events and messages and rows into the lake base, so you have all types of options. Outside of that, you can also reach out to the cloud provider services if that's of your need. For example, if, I don't know, maybe like to trigger a function outside of Databricks or something like this. And indeed, you can reach out to the external APIs if that's required. The external APIs, however, are subject to serverless egress gateway. So apps are under the common security pattern of Databricks serverless, and there are certain network boundaries, such as security egress gateway. Apps will comply to it. Now let's talk a little bit about, okay, but which user will do the actions? Like, will it be the service principal? Will it be the user identity? What exactly is happening there? And this is the topic that many people don't get, and I'm really happy to present this to you. There is a whole separate session from Andre, who is the main engineer behind the apps, about the OBO and how it works in detail. I would like to focus on specifics of usage, right? So by default, when the app is created, there is a service principal created for it. And usually the service principal can be used to perform some actions which are outside of the user context. For example, you can expose a UI which will customly create prepared workspaces for your departments. In this case, this action should be properly executed under the service principal, and this is where you will use it. And you can grant this service principal access to the resources. Okay, but sometimes you want to access something in user context, like a table, or send a query to an agent, or execute something and see the result exactly as the user would like to see it. And in this scenario, you would like to use something that we call OBO, on behalf of, and this is really easy to use inside the Databricks app. One more thing to mention is that you can have two Databricks clients in the same runtime, in the same application. One can use the service principal identity, and another one will use the client identity. Okay, so how OBO works in this perspective? Practically in the following way. When you are sending a request to the app, it can come from two sources. It can either come to the API, like through curl or REST API or Python, or it can go through the browser via cookie. If it comes from the browser, it's a UI authentication. We perform that for you. If it comes from the curl or any type of programmatical client, it still hits the control plane. We will still do the verification. It's just a different way of providing the identity. So what we will do on the control plane, if the user is correct, if the token is correct, and token is correctly scoped, because applications have access to different scopes, then we will pass this information. We will generate a temporary token, and it will also tell you who is the current user reaching out to your application, and it will go directly into your application as a header. There are two headers. One is called x-forwarded access token, another one x-forwarded username, if I'm not mistaken. So what you can do is that like in this code example, this is an example for fast API, but I'm sure you can adopt it for anything. We initiate the workspace client based on the current request, and then we execute the query based on this information, and we can just look up the current user and return the user details, like a quick example. Okay. How we can use Databricks SDK, other SDKs with OBO. Here is a quick example on the left side where we can query a specific table using the user identity. So we receive the token, we pass this token into the SQL.connect function, and then we execute a specific query, and then we return the result back to the user. Another case is, for example, I want to reach out to a serving endpoint, for example, to a chat endpoint or LLM endpoint. In this case, again, I'm receiving the token, initiate the workspace client with it, and perform certain actions on the Databricks side. Important thing, you can use both service principle-based workspace client and user in the same step. So for example, your business logic requires one action under automated user, another action under like under the user context. You can combine. You can do both at the same time. Okay. So assuming we implemented all of this cool logic, now our application really has, cool connections to the Databricks SDK and API. We elevated the user experience. There's just one small thing before. We need to test it, like how it works, how it looks, is it fast? Can it load the handle? Can it handle the load, sorry, so if there will be many, many incoming requests, how will this work? And at this moment in time, we would like to do some application testing. Giran, back to you.
Thank you, Ivan. So in this particular segment, I'm going to cover just a little bit of a foundational knowledge. So we'll talk a little bit about the testing pyramid. Everyone loves a good diagram, so we'll break that down. I'll talk to you about some of the things that we can do from various different testing strategies. We won't cover all, as you can imagine today, but we'll just give you a little bit of a grounding in terms of what some things that you can do today. And then I'll actually demonstrate them from what we've been talked about, as mentioned. So I don't know if many people have seen this diagram or an incantation of it, but the testing pyramid just gives us a way of visually describing testing strategies for your application and your organization. So similar to Drake, we start from the bottom and then we go to the top. I would recommend starting very much to what we would deem as a unit test. So going from top to bottom, we refer to this in terms of complexity and cost. And what I mean by that is at the bottom, these unit tests are individual pieces of work that test individual pieces of functionality. They're very easy to implement. They isolate to identifying individual pieces of unit of work for a particular function. And then they can be run very, very quickly to run. So we're not expecting these types of tests to take minutes or hours. Once you have your tests covered for the individual pieces of functions, you may then want to start looking at how these services integrate with each other. And therefore, they deemed it as integration tests. So let's say, for example, it might not just be, let's say, calling an API. It may be then I call the API, and then I may want to perform some additional kind of translation on that API, and then push it out into another system. Well, that's now integrating 2 or 3 different units of work. So how do we make sure we cover that? And lastly, at the top, we go into more what we call system or integration tests, or even end-to-end, sometimes it's sort of called. And that's actually testing the validity of your entire system. So I'm a user, I log in, I may want to start doing my query, I may then want to understand what that data looks like, and as well, maybe I want to export that to Excel, because that's where all works end. But that's just to give you an idea of some of the things that we're, or how we will enable organizations to do their testing, and I'll cover that as well. One thing to bear in mind is it's great to have a functional application, but there's a question on, okay, how do we move things, or how do we get things to production, and how does it work in a production setting? And this is really where load testing comes into play. It's like, as you scale your application, not just taking it from your desktop, but making sure if you've got hundreds or even thousands of users in your organization, can it perform, can it meet things like SLAs, especially if you've got a critical application, how can you identify and make sure it works as intended? So again, I'll cover that in a little bit more detail. In terms of the testing frameworks used today, again, if you are writing things with Python, you probably might be familiar with things such as called PyTest. There's also the inbuilt unit test as well, which is, again, PyTest is wrapping around that, but PyTest is the de facto way of testing your Python application. You may then want to use things like Faker. So Faker is a cross-purpose library that allows you to generate synthetic data. So again, if you generate loads, do a test against that, it'll be pretty important. And then as you're moving to the sort of system tests, as I mentioned, the end-to-end testing, and you want to click on the user interface, you could use a library like Playwright, which is actually cross-functional, and I'll walk you through that. On the middle side, if we start looking at the JavaScript ecosystem, it has an analogous things there too. So unit testing, Jest, is pretty much used for functions as well as components. If we want to start looking at integration, even behavioral type of testing, you have a more abstracted framework with Jasmine or Enzyme. There's a variety out there, but these are kind of the more common ones that are used. And similar that end-to-end testing, Playwright's also supported in JS, but we also have Cypress there as well to simulate user interactivity in the browser. And the last final stretch is making sure it works in production. So again, we'll be looking at things like Locust for load testing. That's a Python very specific library. But if you come from the Java world or C world, Gatling and JMeter are also credible capabilities you can use as well. Okay. So with that in mind, let me switch over to my demonstration app, and I'll walk you through some of these capabilities. So I have, actually, let's just bring up the application here. So I'll close that out. So yeah, don't shoot the messenger. So in this particular application, I have a simple task manager, like a to-do list, effectively. So it's a CRUD application that I can use to insert tasks, edit it, update, and delete, so forth. So just to give you an idea, if I want to add a specific task, I can say like to do social media. I can't even spell. And post, I've got that there. That's enabled. It's visible. It does what it says in the tin. If I take a look at the application code, okay. So what I'm running here is a Flask application that's served in real time. This is the specific function call for creating. So as I'm sending a request through the browser, it's hitting this endpoint. It's picking up a local database session. In this case, I'm actually using SQL Alchemy. Swap it out whatever database you want. I've got a data model there that was created in Pydantic. So again, ways of being consistent. And then I'm committing that to the sort of database. I've introduced a time sleep here just to say, look, this is what could happen when you're doing an actual database, but the principle still applies. If I flick over to my test suite here, you can see that I've defined a class. So this is Python specific, PyTest specific. So every test suite will start with a capital, class name test, capital T, and the relevant test individual piece of functionality has a test underscore. So in this case, I want to create a task. I'm firing a response to my task API, and then I'm also doing an assertion to make sure that I'm getting the right response. It's interesting at the moment because even though this says client post on the API, I'm actually not running the API. I'm actually using a methodology called dependency injection. You might have heard this as called a mock or fixture in other realms of work, but the idea here is when you want to test your code, sometimes you may not have access to that environment. But what you want to do is test the implementation of that code. So I'm saying if this client was running, what would the response look like? So in this case, when I'm doing this application here, in this case, I'm returning this JSON structure and as well as a return code of 201 to signify I've actually entered something into the database. If I did something like modify this and then run the test suite again, it will give me a failure from that perspective. If I take a little bit further in terms of, so that's looking at a kind of more for a unit test at the moment. If we want to look at things in relation to user testing as well, we can flick over to Playwright. So I'm going to take a look here and look at the user journeys API. So just to give you an idea is I'll take a look at adding the task journey here. So again, another type of thing where we're actually able to spin up a browser session, and then on behalf of the browser, go in, do certain changes, and then see what the results of that to do. Maybe to help demonstrate this, because there's a lot of code, is I'm going to kickstart that test suite here at the moment. So what I'm doing, my hands is off the keyboard, by the way, you can see, and
I'm
again,
also not doing anything, guys, so it's not magic.
So yeah, as you can see, the test suite is actually going in, spinning up a browser session, looking through my application, and doing these critical user journeys. So in this case, again, I want to create a task. I want to modify it, then I want to delete it and wipe it down, and does it render the page? So again, that's an example of working in action. Assuming those user journeys work, I then want to test this in anger, and this is really where I want to use things like Locust. So if I go over to my testing here, so Locust, what I can do in this stage is this allows us to simulate user sessions and do a variety of those user journeys that I talked about. But then I have the ability to then scale up over a specific defined time period. And this could be really handy because I think a lot of you here today have probably seen through various different application testing is it could be 8 o'clock in the morning, whole bunch of analysts or users access an application, and then they're having that spinning wheel or hamster wheel because they're unable to access the page. And these are the type of things that if we've done load testing before, then we're able to identify those bottlenecks and then fix them. But just to give you an idea, so let's say I've got this application now and I'm giving it internally to 100 users. I may say over a period of 10 users at a time. I may want to see how does this perform over a 30-second period. So in this case, I can go ahead and spawn those tasks. So in the background, Python is spinning up individual threads. It's then hitting those APIs. So this is now doing a live test. So the application is running, and you can see here over 60 requests are hitting the server at the moment. And if there's a case that we even scale this further and we're starting to see failure rates, then it's a case of us understanding have we sized up the machine accordingly and so forth. But it looks, again, we've done a very simple simulation here, but as you can see, nearly 90 requests per minute, hitting the task, creating new task in Task Manager. And if I hit refresh here for a second, you can see I've got 600 tasks, or nearly 600 tasks have been generated as part of the load test as well. Okay, so with that in mind, assuming we've tested the application, we've proven that it's worked, how do we actually move this from that development to a production state? And Ivan's going to talk about that process in more detail. Thank you.
Thank you, Giran. Yeah, assuming Giran was the guy who tested and prepared the application, and now I'm just just a DevOps guy who needs to deploy all of this, somehow just throw it out into prod. So, quick question here: who of you have ever written a CI pipeline? Oh, that's great. Okay, I will just skip this.
That's better than I was expecting, actually.
No, okay, that's great. Okay, and who of you have ever had a CI pipeline fail in production critically when you're trying to roll out that bug fix live? Okay, that happens. Yeah, my example probably shouldn't do this. I hope at least, but demo effect could be with me. So for those who are completely off the chart, right, what's happening with CI/CD nowadays? Two pieces. There is continuous integration and continuous delivery or continuous deployment. There is a big fight about how things should be called. I will not go into that. In our terminology, CI is everything that happens when you write the code, build the code, and run the tests, any kind of tests. And then staging/production is when you roll out the application to actual users, and these are two substantial and different parts of your pipeline. Okay? How do we help with this CI/CD journey? So Databricks Asset Bundles are standard for Databricks deployments when it comes to deploying data products, right? I mean, if you want to deploy infrastructure, you can consider using Terraform, but usually the data teams who actually develop the data products, they rarely would like to write Terraform because it's a completely different skill set and a different way of doing things. The cool thing is that Databricks Asset Bundles fully support Databricks Apps. So what you can do is that you can describe your app definition, including the resources, including tags, including names and everything. And this will allow you to easily deploy your Databricks app multiple times through the CI pipeline. So you can deploy your application first time to staging, then to production, right? So you can like roll it out on staging, get some user like feedback, and then if everything is fine, you go towards production. The cool thing of bundles in this perspective is that applications rarely live on their own. They're usually connected to some jobs which populate the data, some SQL, some models, and so on and so forth. You can conveniently describe these things in the Databricks Asset Bundle and then connect them all together in a single file. One thing about the format, I personally don't like YAML. Unfortunately, we have Databricks bundles SDK in Python, so you can describe all these things in Python and they will be easily deployed. Okay, now assuming we have written this definition, right? Now we would like to understand how our CI pipeline would look like. So first of all, your application code must be in some kind of Git storage. It is an absolute like must. All things should be there. Like it should be there for versioning, should be there for code control, and many, many other things. Which provider do you use is completely up to you and your organization. You know, GitHub, Bucket. There are many, many options. All the Git providers have some kind of CI built in, what you need to do as a developer is that you need to describe your application and its dependencies in a DAB format, in the formats of YAML or Python, right? And then you need to use your Databricks CLI inside your CI/CD pipelines. Logically, I usually, like if I'm being asked, so what is CI, what is CD, how do we split this? I usually recommend to think of it in the following way. So on the greeny side here, right? What happens is that developer pushes something into the feature branch, and we will install the dependencies, run unit tests, deploy the new version, and run integration tests. And all this usually happens in the testing workspace or like several set of workspaces. And here we are interested in collecting as much as possible, you know, coverage metrics, locus test results. Playwright can do video captures, so you can, you know, watch why the pipeline has failed, and so on and so forth. And all this goes in the feature branches, and multiple features getting merged into main one by one. And at some moment in time, you decide, or a manager comes and says, we need a release now, which case happens more often, is up to you. But you decide that it is the time to do the actual like deployment to production. And usual scenario is that we are using a release, we create a release, and this creation of a release triggers a CD pipeline, so the continuous deployment pipeline, and it usually takes the pre-built package or builds the package and deploys the new application version, but now towards the production workspace, and maybe it, you know, collects some release, pre-release information. What do we have in terms of tooling for this? So first of all, Python projects, I mean, you can use requirements.txt, nobody will limit you in doing that. But we see a lot of UV adoption recently. We are also planning to introduce native UV support for Databricks apps. So, you know, if you're choosing the package manager, UV is probably the best choice. You can also use like other project managers, package managers in Python, but you will probably need to write like a small custom hook to generate the requirements.txt. You can use the self-hosted PyPy registries and put your application code in there and then install it when you're starting the app. Just a common recommendation, right? So you can split like your code into like the actual application logic and just common sets of things that can be reused, like the domain model, for example, and so on and so forth. In terms of the CI/CD setup, currently the proposed way is that you use Databricks CLI, and then you use dabs to deploy your application to several workspaces. And you can use variables to kind of specify application behavior differently depending on the different stage. For example, like in production, use this catalog, in development, use this catalog, or this schema, or this model, and so on and so forth. If you have Databricks network access policies, in this case, you would like to use the self-hosted runners which are running inside your network, and they reach out to Databricks. We're also planning to introduce something which can remind you of something like Vercel, when you have a hook which is constantly on your repository, and as soon as you do a push, it automatically triggers everything into Databricks. And this will be kind of a managed experience, more or less. This is on the way, not there yet, unfortunately. Okay, so now I'm going to do what nobody likes to do, is to make a release when there are many people standing and looking at you at the same time.
No pressure.
Yeah, but I hope I will be successful in this task. This is my application running on Databricks. This is a really simple application. What it has is it's just one UI interface, which shows that this was deployed automatically and the current version of this deployment. So what I can do now is that I can go and just create a new release. Let's increment this. Let's assume we added some cool feature or something like this. Let's hit this. So it's going to have the same title. I will leave the comments blank, and then this is not a pre-release. So I'm gonna publish my release. And what's going to happen is that this will trigger a CD pipeline. So this is a CD pipeline now because it's the deployment pipeline. And we can quickly take a look at the code of this pipeline while it is running. It's going to take like 30 seconds or something. So what this pipeline is doing is practically, configure the secrets, install UV, build the package, deploy to Databricks, and run the new version of the app. This is really like a no-brainer, very straightforward thing that is happening here. If we take a look at our actions now, it has been already finished. I was talking too long. If everything is fine, then refreshing this page should give me 0, 1, 9. Are we good? We are good. Perfect. Yeah. So this repository, by the way, that I'm showing to you right now is also open sourced. We will add this repository and all the repositories you have seen today into the presentation, which will be given out to you afterwards. Okay, good. So this was the story about the CI/CD piece. And now imagine that you tested it all nicely, you deployed it, and now the application grows. Complexity grows, you have more and more users coming, and you want to scale it out. You need scalability because, because as soon as your application getting popular, you will have a lot of users. Anecdotally, we have an internal application which has more than 2,000 users, and we have other customers where we're also talking thousands on Databricks apps. So what do we have in terms of best practices for apps scalability? First of all, in terms of development and deployment, before deploying, run your application locally with the correct Python version. Check that everything is working fine. Do not use pet tokens like completely. Connect to Databricks using OAuth. This is really simple. This can be set up pretty much in every scenario. And use the testing frameworks as we have demonstrated, as Giran have demonstrated. That's how you can do it. Yeah. In terms of the deployment, use dApps because it's simpler and more straightforward. Have a CI pipeline to run your unit tests. Have a CD pipeline to perform the deployment. And really a big thing to recommend, have separate Databricks workspaces, one for dev, one for prod, or like dev test prod, and deploy your application in a staging way. Right? If you need to act on behalf of the user's identity inside your app, don't try to grant all permissions to the service principal. Instead, use OBO in your application. This is a relatively simple thing to do. You just receive the header, initiate the client, and perform what needs to be done. Okay. In terms of runtime and performance, well, first of all, we're well aware that 2 CPUs, 6 gigabytes of memory is probably not the most biggest amount of compute we provide. We're going to work on that, and we will talk about this in the roadmap piece. Even from these 2 CPUs, you can actually get quite significant results. But we need to apply a couple of rules here. Well, first of all, if you're using the DB-SQL connector, it has async operations. And it's really recommended to use them because in this case, practically, if you use a non-async operation, it just takes the whole core, like completely one process takes one core. And if you have 2 users, you're at capacity. If you have 3 users, somebody's going to wait, right? if you have a UI with heavy customizations, like 3D visuals and things like this, you probably would like to use JS, TS, and Python in the backend. Why is that? It's not because Databricks apps are built differently. It is because of the way how Python frameworks work in terms of front-end code. So what is a Python front-end framework? It's practically every single user is a separate WebSocket connection, which constantly opened, and everything that user is doing on the client is sent in the form of message back and forth. This works nicely for many use cases, but if you have, let's say, like 3,000 users or something like this, you may have performance issues, especially if the application doesn't support running several workers, okay? So what do we want to say with this is, like, don't use Python? No, wrong statement. It's just that if your application is planned to be scaled out to, let's say, like 2,000 users simultaneously, just apply some common sense in terms of how you run it and use a synchronicity where it is possible. And this is exactly about like small detail of implementation. If you have a long-running operation, do not keep a running core around it constantly. Instead, create an async or task and let it just check the status periodically. In Fast API, there is the background tasks that are very convenient for this task. You don't need to keep a constant connection to check the status. You can do this like in a status pool fashion, when once per 15 milliseconds you kind of check the status of the query and send it back to the front end, for example. Okay. In terms of just common sense, Python projects have a problem that versions, especially if you use just requirements.txt, you are allowed not to pin the dependencies. This can lead to so many problems, especially for long-term running projects. It is really recommended to pin your package versions using UV or any package manager of your choice. If you are going for Pythonic frontends, always run your application through UVcorn, Gunicorn, or something like this. Why? Because if you run just one single instance of the application and one user may take all up the memory or may crash the process, it will be crashed for all. If it's UVcorn, per each user there is a single lightweight thread, and if one user fails the thread, well, not a problem, we will just restart, and the next user will receive the expected experience of the application. So process managers like UVcorn, Fast API works nicely with UVcorn, Flask uses Gunicorn, if I'm not mistaken. Yes. Yeah. So you can have a combination, you can have a mix there. Yeah. Okay. Now let's assume that I have been following these instructions, I tested my application, I made my CI/CD pipeline, everything is nice and shiny, and I want to understand how the users are doing, what they're doing in the app, how do we monitor this, how do I observe these things. And at this moment, I don't know anything, but I can only call Giran to help me.
Thank you, Ben. Okay, so in this section, we're going to talk a little bit about monitoring and observability, and we'll dig into it from the perspective of what are some of the capabilities that we have in Databricks apps today. I'll also touch a bit of a sneak preview in terms of what's coming around this particular area, and then talk some of the capabilities of how do we then improve the application through this lens. As Dr. Dre said, what's the difference between monitoring and observability? So just to kind of break it down to the folks in the room, monitoring really focuses on the what and when. So it's kind of the historic look back. So an event has happened, something's been written to the log, and it's identifying things which are known, okay? So, and this is really around, I wouldn't say reactive, but it is, for lack of a better word, right? So something, let's say an application crashes, what do? Check your syslog, you see it pop up. Observability, on the other hand, is this kind of new paradigm, especially with the movement from the DevOps that have happened in the late 2000s. It's answering the why and the how. So it's for those sort of unknown and unknown knowns, if that makes sense. So it's peering into the application itself and identifying, especially when things might start to occur, and especially the change in what we're seeing, breaking down a monolithic application into a microservice framework, as you've probably seen in individual pieces, is being able to kind of trace the events throughout these systems. So if you're starting to go down this route, and you might have been doing it with some of your peers there today, this is really where observability shines, is being able to answer these questions. And it's worth pointing out together, gives you a full view. So you don't use either or, you really need to have both to construct this view. And also give you a feel of how you can best improve on the life cycle of your application. So again, really critical is that monitoring will tell you something that has happened wrong, whereas observability is focusing on the what and the why and the how. Okay, when it comes to monitoring applications in Databricks today, we do provide some out-of-the-box tools. So application logs, again, you've probably seen the application definition, we've got the configuration. There's another tab there for application logs, and this shows you things piping off from the standard output. So if you do something like a print or use a logger library, by the way, this is, I would say, to everybody out there, please use a logger. I cannot see how many people have just written print statements and they don't even know what that print statement is. But if I could have one takeaway, it's just making sure that you have this in place where you've got a clear timestamp, you've got the right information level in place, especially when things are critical, and it allows you to identify issues a lot clearer. And if you look at the box below, this is actually providing a standard log which you can then search in the UI. Just something to bear in mind as well, these logs are written from most recent in reverse chronological order, so that kind of threw me away as an application developer because I'm usually using tailf-log, but now it makes sense because you want the most recent and most critical thing in your view pane. So just something to bear in mind moving forward. Again, really important is that when these apps are ephemeral, so these logs are ephemeral, so when you shut down the application and reboot it, it's completely wiped. We don't have a history or session of that. And if you are using secrets through the configuration, those will be redacted. So again, we don't want people spilling that out. There is a question people have been asked is how do we actually publish that logs into Databricks, into Delta. There's no native way of doing that, but there are ways which we can give you mechanisms to push that into a table as well. So that's just about customizing the logger to then either push that through a volume or even write to Delta table as well. So we have options in place. Another thing that we do, again, assuming a lot of users, but I don't want to make any assumptions because they're dangerous, but if you're using Unity Catalog there today, you will also come through a capability called Systems Tables, which is effectively a way of providing native observability into Databricks. And as part of that, we're actually instrumenting a variety of surfaces, especially in relation to things like audit logs. So we can tell you which users logged into the application, how long they've logged into the application, and some of the things that they've tried to do with that. So especially, again, for more highly regulated customers here in the room today, we help provide that out of the box, and that can actually be tied very closely with our security framework as well, if you've come across that. So again, ways of just giving you that visibility of who's having ownership and whatnot. One thing I wanted to talk about is around getting to the observability piece, and I wanted to focus specifically on OpenTelemetry here. And then for those who aren't familiar, OpenTelemetry is an open source observability framework for collecting telemetry data. And I think what's really important as for an organization like Databricks is we're built on open source, open standard, and open toolings. So for us to talk about this is very important here today because we want you to, regardless of whatever monitoring tool you're using, so some of you might be using Grafana, Datadog, Splunk, OpenTelemetry allows you to create that agnostic framework. So if you decide to use another tool or you want to expose that data even into Databricks for consumption, that's all possible there today. So there's something when we're walking through the demonstration, I just want to kind of call it out there. It's combining these best practices just help you, again, own your own data and own your own IP. For those who may be familiar, like the core tenets of observability are sort of three things. So logs, you were probably quite familiar with already. There's a second piece called metrics, and also tracing. And in this particular slide is just talking a little bit about how do we actually see that journey of that request. So we refer to this as a span, so something that covers, let's say, the life cycle. So let's say, for example, a user clicks on click to basket. So that's going to be called an API in the web UI. that web API then might call a particular database. And in that database, it may write to a particular data source. So it's going through various different tranches to actually make that happen. But important is actually understanding down to the wire where that fundamental piece of failures might happen, and tracing allows us to pinpoint exactly in the stack or where that might go wrong. So, and especially if we're moving to that microservice framework where you've got APIs calling other APIs and you're orchestrating that, it can be very difficult if you're just looking at it from logs. So this is why tracing becomes very, very important as well. Metrics, again, another very critical thing to observability, not just looking at in terms of users, how much sessions are hitting a particular endpoint, but we may need to start looking at things in relation to the application code itself. So, what is kind of my throughput to a database, for example? I can create a gauge or a counter to do that. And it's interesting, is like if you're starting to see, coming to when you're doing things like load testing, you may want to create certain metrics to identify where the bottleneck might be. Because it might be the case that, again, sometimes we may be even limited by vertical scaling. So it doesn't matter how much we scale up a database, if we can only push a certain amount of connections on that particular node, we may then need to start scaling horizontally, for example, to support that. But we can only understand that if we start tracking metrics along with other observability points, like maybe we're looking at network stats as well as CPU and so forth. So again, it's just about collecting as much information as possible to bring that clearer picture into place. When it comes to dashboarding and alerting, again, all rules, I'd say read to Excel, but S3 is really critical. So when you're collecting this telemetry data using OpenTelemetry, there's a few options. You can either send it directly to a third-party provider as well, to whatever endpoints that they take it. Another option is building your own telemetry stack. So a number of customers that I've worked with as well collect this through a collector. So that could be typically like a Docker container or Kubernetes cluster that all of your applications are firing telemetry there too. It's then collected in a database that can then be visualized through any other tool there as well. Really critical to especially how Databricks works is you can actually export this telemetry information directly to S3. And what's great about S3, folks, is that, again, we can create things like delta tables straight off of that. So that information is available, we can extract it for further use downstream. And again, when that information is available in Delta, we have out-of-the-box capabilities there. So again, you've probably seen things like dashboarding, where we can do quick as a graph, and again, understanding how the user is operating, maybe through natural language, through Genie as well. Okay. Something as well that we're seeing, and this is a bit of the current iteration, but just to give you a glimpse into the future as well, we're actually redoing our alerting capabilities on Databricks. So we're going to be offering more sophisticated ways of not just understanding when jobs and other compute types go wrong, but actually if you're doing things like querying or other sort of observability, we can then alert and send that information out through a webhook, or even if you've got things like PagerDuty, for example, you can take a look at that real time. So again, if there's an issue with the application, again, we want to move from that reactive to a proactive approach there as well. Okay. So in this stage, what I'm going to do for the sort of last segment is talk about, okay, that application I created earlier with the load testing, what does it look like when I've instrumented it, and how can I look at what some of the data points that I'm getting? Okay, so if I go back to my application code, right? So I'm just going to take a look here at, let's say, create task. So for example, in the create task, this is on the Flask side, by the way. So you can see I've got a request, or in this case, I'm creating a gauge or a counter. So I'm saying, in this case, take an observability point that I'm actually adding to this queue. I then want to say something called a trace context. So in this case, I can actually extract things. I can extract unique information from my front end. So I actually do have front end observability, the same OpenTelemetry information available. So let's say I have a specific request ID. That request ID can be translated right across the stack. When it comes to spanning, so this case that's when I set up that parent kind of tree where I can start to instrument. And what's great about OpenTelemetry is this is a very easy SDK. You just simply use the decorator here, the context manager, to say create the task. as a span, and then you can set specific attributes here. So in this case, I can get the request ID from the front end. So this is unique as well to when you log into Databricks Apps, this header is available, and then push information in relation to that request. So in this case, when I'm creating a task, I'm saying this is the title. I can have that logged in and then being pushed to OpenTelemetry. You would have seen here as well tracing the info. So in this case, I'm also sending that information back to the telemetry tool. So this is where I talked about, combining both the logging as well as the observability data there as well to give you that full stack. And really critical as well, if there are errors, we do want to encapsulate them. So in this case, I'm also using an exception block. So it's really key to us to understand that behavior. And what I've done here is I'm going to go into the application. So again, I'm making some changes. So let's say I'm just doing now a delete all. I'm flushing that out. So I've now DQ'd that. I'm actually going to look at my observability tool here. So in this case, I'm just going to click on reload. I'm using uptrace here as the system, but again, you can swap it for anything. If you've got, again, a Datadog, Grafana, it really doesn't matter. At the end of the day, like it's all on a standardized tool. But really critical to how this works is, we're tracking, again, very deep information in relation to how our application is running. So if I take a look at, looking at the front-end tasks, actually, maybe I want to, let's bring the hour back. So let's do it to the last 6 hours. Okay, so let's take a look at, you can see again, when we were doing sort of the load testing earlier, again, this is really critical to see how your system is operational. I'm going to take a look at backend task here. Okay, so let's take a look at when I wanted to create this, when I wanted to create a task. So bear with me a second. Okay, so it's around there. Okay, so this is, again, where that sort of tracing comes into play. When I create, I'll send a request to the front end. I'm issuing a post request. Underneath that, I'm then saying create task. So that's the individual, pieces of functionality in the Python core. And then I'm actually, you can see even further going into the database. So this is the connection to my database instance and what's happening. I've even got an instrumentation on the database itself. So if it's the case of like, hang on, I'm been able to send all of these users through load testing, but I'm not getting any writes, we may need to identify exactly where. Is it something in my implementation of the code, or is it something in the database I need to configure? But you can only do that if you understand the telemetry information, and again, this is why tracing becomes so important to that. So this is, again, a bit of a whistle-stop tour, but again, this moves beyond just looking at application logs, and observability is really powerful to help enable this. With that in mind, I think we're on time, Ivan, so I think we may want to talk about, what's next and for the team.
Sure. So assuming you developed your application, deployed it, love it, and you were thinking, okay, what will Databricks do in the future to make my application experience as a developer or as a user better? So let's summarize this and give you some glimpses into the roadmap. First of all, when yes, when no for Databricks apps. Yes, in case if it's an exploration for your data, if you have any data-connected services, database APIs, chatbots, RAG, LLM endpoints, MCP servers, custom ones, complex custom visualizations, practically, anything related to this. And also a quite important thing is when you want to expose a curated set of Databricks APIs to specific users or specific user groups. Where we want fit right now. Mobile apps, a little bit not our area at the moment, let's say. Static hosting, static content, just a little bit too costly. If your content is static, you probably can just serve it from GitHub pages or something like this. It's not the case for Databricks apps. Although I've seen customers who are serving, like they have several projects, they all have dbt docs, and they're just serving them all inside the same single application. Possible. Not yet we are there, but there will be a possibility in the apps at some moment in time to make your application have fully public facing. So you have a URL, you can send this URL to like on the net, and click there, click through, and get kind of a login into the application. In terms of where I am. Okay, in terms of let's recap what we were talking about. First, applications are GA. GA as in full support, full production, and things like this. GA also means that we have added most of the regions for the serverless support, so you can easily scale. You can easily run up in not only just like Europe Central or something like this, but in all regions, almost all regions. The idea of apps is that we take the data and AI capabilities of your platform, and we give you the tool to prepare a curated experience for the end business users, usually. And it's a great tool for several sides. So if you are a data engineer and ML engineer, you can just quickly write a simple application in Streamlit. If you are a software engineer, you need something more complex, more profound, you still can use your well-known tool stack like Node.js, Python, and with Lakebase also Postgres, so kind of in the light of the recent announcement. And if you are from the business side and you think, okay, so why would I consider like using apps or not using apps? What would be like benefits? There are three things. Apps are easy to build. They're simple to operate, and you can easily scale them in terms of amount of users. To get the data, to get the value from your business data, from your AI services, building a fast and flexible UI and having the chance to quickly experiment on your own is a great opportunity to drive business value out of this. Good. Giran, would you mind talking a little bit?
Yes. So I think in terms of the, what's now, what's next, and what's towards the future, I want to kind of break it down into these various different three themes. So I think scalability is, one of the big questions that, especially in our internal chats and lots of our customers have pushed. It's like, 2 CPUs, 6 gigabytes of memory. Come on, it's like, what's that piece of device that you just you plug in? No Blueberry. I keep forgetting
Raspberry Pi.
Raspberry, that's it. Yeah,
Raspberry Pi.
It's a long day, folks. Long day, right? It's like my Raspberry's got more resources than that. I'm like, okay, I get it. So to address this concern, we'll be introducing more like T-shirt-based sizing. So we'll start from kind of a small, medium, large, and so on. So similar to what you're seeing with SQL warehouses. This also includes not just vertical scaling, but as well as horizontal. And what we want to do is, especially for users who have, let's say, a dynamic structure where they need to scale up and scale down and be that flexibility, this is something that we're considering as well as part of it. It's very easy for us to scale up our infrastructure. So just want to put it out there. The real difficulty is actually how do we determine when to shut it down? So what that means is we're looking at ways of, again, if a user's not logged in a particular time period, maybe you want to spin it down to, again, help you manage your costs in your organization. When it comes to observability, so I know I'll walk through this in a very piecemeal way, but something to bear in mind moving forward as part of the new releases, we actually enable observability out of the box. So the instrumentation that you do can still be done, but instead of you shipping things off either locally or doing to a third-party service, you can just send that directly to Databricks, and that will be available for you to natively query as needed. So again, just focus on instrumenting your app, and we'll take care of the other heavy lifting for you. When it comes to, again, monitoring how the application is functioning, so like a CPU, memory, and networking, I know it's not the most attractive thing to talk about, but again, when you're deploying things which are critical, you want to know that fast feedback and see how your app is operating, you need this level of information. Key thing as well is, again, it is GA today. We do have SLAs, but again, for organizations who are supporting highly regulated, highly critical workloads, we want to give you as much uptime as possible. So again, number of ways which we're bolstering the service. There was also a question that keeps constantly getting asked around when it comes to availability, and we're actually also GA when it comes, apart from maybe, I think federal government or GovCloud, but we do have enhanced capabilities now. So if you've got HIPAA workloads, PCI DSS, and so forth, that is supported on Databricks Apps. So I just wanted to kind of throw it out there if you weren't aware already. And this comes down to the governance piece, because at the end of the day, you're using Unity Catalog for your data there today. You're using your entry, your single sign of applications. We then want to take this further and move it into even the code-based application. So looking at ways which we can use effectively treating your deployment and your application as code in its entirety. So I would say it's an evolution of dabs to this. So dabs will still be used underneath the hood. But what we want to do is say, look, here's, if you ever use things like Azure DevOps, you've got your code there. You've got a button to say click to deploy from that code. So again, you can use things like branching and so forth, but again, natively to Databricks. Systems table, so we've got audit systems out of the box, but when it comes to additional workflows in terms of that CPU, that telemetry information, that's something we're thinking about moving into systems tables. Again, giving you greater visibility included out of the box. Again, something that you don't need to write to Delta yourself. And really critical around is how do we then not just enable users to create applications, but how do you do it in a reliable way at scale? So if you're an organization that has a very specific way of creating applications, whether that means you use a specific framework, this is the way you define how your components layout looks like, this is how you integrate with services, well, now you can create a template in your organization and have that available for users to pull from that template. So they're not deviating against different standards that they might just find from the internet. There's guardrails in place which you can trust. And this kind of ties nicely into things that we're announcing around the marketplace. So stay tuned for that very, very soon. Something to point out as well is, and I know the team have done an amazing job trying to hobble this together, and I appreciate, it's going through the phase around the documentation, but we've got an amazing colleague by the name of Pascal Vogel. He's done a fantastic job with Anton to rehaul some of that documentation and put the application cookbook. So at the moment, it's on an open repository, but we're looking at bringing that today. They provided recipes out of the box in terms of, like, let's say, connecting to Unity Catalog volume, writing, how do I query this data, how do I query a model serving endpoint, and things you would use as a common, let's say, stepping stone to building your application there as well. The documentation, as I mentioned, is getting rehauled, so we're going to simplify a lot of great things, especially being GA now. So as you've seen, it was very easy for us to create an app with 2 or 3 different steps. We'll have that reflected. There's also a demonstration. Again, we'll provide these slides for your user, as well as the GitHub links as well. But yeah, that's available for you to consume. And I think a lot of things as well, again, we've covered a great deal in a short space of time, but if there's things which you feel you want to dive a little bit deeper onto, then please reach out to your account team. And if there's things that where Yvonne and I can join you with the right stakeholders on your side, then they're able to kind of facilitate that and help accelerate some of the use cases that you're thinking about as well. Awesome. Yvonne, I don't know about the surveys, but I think
let me summarize on this. Yeah. So thank you so much, guys, for attending our session. This is officially the ending part of it. When you will be out, you will get the complete your surveys request. If you liked what we did, please let us know, or if you didn't, then please let us know too. Thank you so much for your attention.
Thank you.